Hi, this is Karimullah Sheikh. As part of Infinity Ideation Program, I am presenting my idea on emergency assistance system. The agenda of this presentation: problem statement, solution overview, digital twin technology, proof of concept, actionable insights. The objective of this project: if there is any emergency situation occurs due to a car accident, based on the situation, it will be very difficult for a driver or co-passengers to get help on immediate basis. If the injuries are serious, it will be very critical for their survival based on the help that they are getting in the critical hours. The more delay in the assistance, it may cause a permanent or lifelong ailment, or it may lead to death. So to support this emergency situation, and I have came up with a solution as part of this project. So if we look into that, the statistics, if there is any accident happens, the workflow looks like this. So when an accident happens, there are electronic sensors fixed in the car, and these sensors, multiple sensors will supply the data, and this data on the crash of that car, it will detect that incident, and the airbags will develop based on that criticality of that accident. If we look into that statistics, globally there are 6 million average number of car accidents in the US happening every year. And if we look into this right side, there is a car accident fatalities, it's 1.3 million per each year. And this global airbag sensor market, if we look into this, every year the market is keep on increasing, and the cumulative annual growth of this CAGR is 5.9%. So there is a lot of potential demand for the airbags and that modern vehicles. So to help the customers, to assist them in the prevention of accident, and also to help in terms of their assistance. So this car networking architecture, if we look into this, we have these are the vehicles. They are producing this data, and these moving vehicles, this data is uploading into that servers. So these are the IoT servers to internet. The data is getting loaded into the IoT servers, and the users are fetching that data from these IoT servers. So this is a kind of request and response kind of system. So if we request that, let's say if we want a request oxygen sensor monitoring test result, we can get those details from this vehicle. So this is kind of a request and response kind of systems available nowadays. So the solution overview, using that real-time streaming data generated from airbag sensor, alert the insurance company once airbag is pushed upwards. Immediately, insurance agent will contact and help insured to avoid uncertain situation based on the collaboration with some external parties. And by this way, he can help that the insureds, and also he can, some extent, he can reduce his burden in terms of paying extra, based on the situation. And also this real-time onboarding diagnosis, so it will help the insurance companies by tracking these RTOBD details. They can understand the customer driving pattern better, and they can tweak the individual customers' premiums as well. And moving on to that, this is a data streaming architecture. So this is a big data based streaming architecture and solution. And if we look into this data sources, these are the mainly vehicle data. And this data is captured in the IoT devices, and this IoT servers will persist this data, and using RTOBD data. So this data will be ingested in the NiFi ingestion layer, and this NiFi streaming data will move into this Kafka, and Kafka is the message queuing service, and this Apache Spark streaming, it will act as a streaming solution, and it will take that real-time data from Kafka and the already existing customer data from the Hive data warehouse, like driver details and customer details, and there's policy plans and all those things. And by processing this data, and whoever the customer is needy for an emergency assistance, an alert will be generated to that nearest medical centers, police stations, and friends and relatives. Also, the driving patterns will be persisted in this dashboards using Elasticsearch and Kibana, and we can generate the reports out of this presentation layer. So this is the solution as we discussed in a high level. And moving on to the digital twin. So the solution we discussed is it's a subset of the actual solution of a digital twin. Okay, so emergency assistance provided by insurance company automatically create a car digital twin, and this can be used to alert the emergency service operator if an accident occurs, and results into car fuel pump to shut down or airbag to activate. The alert gives location details and also calls and stays open so that anyone in the vehicle can contact that contact to that operator. And this digital twin operates on 24/7 basis and provide the assistance to drivers for risk prevention and also at an emergency situation. So what is digital twin? Okay, so digital twin, there is a real space, it's like a real vehicle, and there is a virtual space, this is a virtual digital twin. And the real vehicle will send the data to that digital twin, and this digital twin process this data and send the alerts and information back to that real vehicle. So this will always alert the driver if he is speeding or if he is hard braking, or if there is a he is very close to any vehicles. All this kind of alerts it will pass, and it will try to prevent that any accidents. And also, if there is any accident happens, this digital twin will coordinate and communicate with the external parties and systems, and it will alert their families as well, families and friends as well. So as we discussed in earlier slide, the digital twin is also used in electric vehicles. The e-cars can be paired with its digital twin, and IoT sensors are installed on the vehicle so that the sensor can send or receive information from its digital twin. The data generated from the sensors enable to keep a track of working condition of the car and also detects problems early on it in order to avoid expensive repairs. So today, this Tesla is making use of this digital technology for the future and oncoming the e-cars. And moving on to this digital twin, the kind of high-level function flow, and this is a real vehicle, and we have a digital twin, and a digital twin will get this data, and it will control parameters, and reports will be sent back to that real vehicle. So this is a Apache Kafka-based digital twin solution. This solution consists of Kafka ecosystem. It's a TensorFlow, it's a NLP-based machine learning algorithm, and other components. The car sensors will generate the data. This MQTT proxy, it's a message queuing proxy. It will ingest the data to Kafka cluster, and this cluster, this data will be processed into Kafka SQL or KSQL DB, and this processed data will sends back to this Kafka cluster for any cleansing or anything. This processed data will be fed to that on a real-time basis to this near real-time basis to this TensorFlow model, and this model will get trained and creates an analytic model, and this analytic model is deployed into that real solution of Kafka Stream application. And so this real-time data will come into this Kafka Connect, and this critical data will feed to this Kafka Stream application, and this model data and this real-time data will get processed, and it will find out that potential detects, and it will send the alerts. Also, it will process that batch data or other information through Elasticsearch, and it will create the reports using Grafana. It's another visualization tool. So this is a high level of this